Hey guys, this lesson we're focusing on heat of reaction. So when we're looking at heats, remember we're thinking about calorimetry. So calorimetry, remember, is a method to measure changes in heat during a chemical process. And measurements in heat are in insulated containers called calorimeters. And the picture over there is just a fancy version of it. But in the school lab, we usually just use a simple styrofoam cup and styrofoam lid. We can measure the heat capacity of liquids with a calorimeter because we just really need to keep the heat in and see the temperature changes. So heat capacity is the amount of heat needed to change a substance temperature. So we can place a known amount of liquid inside, so a known volume, and measure the initial temperature. We can then heat it with an electrical coil and with a known amount of electrical energy, so then we can then calculate how much energy that is later, and then measure the final temperature. And using this, we use the equation to determine the heat capacity. So remember, Q we're using here is the quantity of heat in joules. M is the mass of the substance absorbing the heat, so if we did water, it would be water. C is the specific heat capacity in joules per Kelvin grams. And delta T is the change in temperature. So what we really need to remember from today is that calorimetry can be used to, measure the temperature changes in reactions, in solutions, but also we can determine the specific heat capacities by figuring out how much energy we put in. We can put that as the Q. We know how much water or whatever substance we're looking at. We measure the mass of it. That means we give us M. And C will give us a heat specific capacity of it. But if this is unknown, we just need to then measure the change in temperature, and therefore we can use that to determine C, the specific heat capacity. So just remember this equation for the questions coming up. So first of all, question 11, why are hydrocarbons used as a fuel? Can you remember back? Are they inert? Well, they're not inert because they easily react when getting burnt. So they react with oxygen. Inert substances are like the noble gases that don't react with anything. B, the reaction with oxygen is endothermic. Combustion, remember, is exothermic, so B can't be correct. D, they are an unlimited resource. Fossil fuels such as hydrocarbons, petroleum, coal and all this are a finite source of energy because we're always talking about running out of it. We need to find renewable energy like solar or water. So this is not an unlimited resource, it's a finite resource. C, the combustion releases a lot of heat energy. Yes, hydrocarbons are used as a fuel, they're burnt. They release a lot of heat energy, which we use, say, in cars to move the pistons, and therefore C is correct here. 12, why do a lot of neutralization reactions have the same heat of neutralization? A, all neutralization reactions are the same. Well, they're not all the same because sometimes we use different reactants, so different acids or different bases. C, they all involve hydrochloric acid. That's not true because neutralization reactions can also use other acids like sulfuric acid. And D, sodium hydroxide is the base used. Again, not all bases are sodium hydroxide. We can use various amounts of bases. So B, they have the same net reaction. This is true because the net reaction is the amount of protons released from the acid reacting with the hydroxide ions released from the base, and that gives us the net of water produced. And usually this is a net reaction, and a lot of spectator ions are involved and produce salts which are not involved in this reaction. So B is the correct answer here. 13. Explain why there's a difference in heats of neutralization in the following two reactions. So in this one, we're looking at hydrochloric acid with sodium hydroxide, producing either salt and a water, and it's minus 57.1 kilojoules produced. The other one is sulfuric acid with potassium hydroxide, and this produces salt and water, and then also it produces 114 kilojoules of energy. So the net reaction we just said before in the other question was hydrogen plus the hydroxide gives us the water. And then the salts are from the spectator ions. So the first reaction, there's 1 mole of acid of hydrochloric acid needed to react with 1 mole of the base, so sodium hydroxide. And this produces 1 mole of water. And that produces this amount of energy. The second reaction though, 1 mole of acid, we need 2 moles of base. If you can see here, 1 mole of acid needs 2 moles of base. And then 2 moles of water is produced over here. So we need to then times this by 2. So the heat of neutralization is different because the number of moles of water produced is different, and therefore we double it. So question 14, what is the name of the container when we are measuring changes in heat, and what property must it have to ensure accurate results? So what we're using is a calorimeter. Remember, that's like the polystyrene cup. And this needs to be an excellent insulator of heat, so we don't lose heat from the reaction into the surroundings, and therefore if we keep the heat in, we can measure it accurately. Question 15, briefly describe how you would measure the heat capacity of water. So firstly, we'll measure the temperature of a known amount of water. We'll then heat the water with a known amount of electrical energy. We'll measure the temperature after heating it, and then we'll use the equation of Q equals mc delta T to calculate the heat capacity. So what we were doing today was looking at calorimetry and its application to looking at heat capacity of water. So the heat capacity is the amount of energy needed to change the temperature of it, and we can use, if we know the amount of energy we're using, the mass of the water, and the change in temperature, we can calculate the specific heat capacity of water.